Okay, so what we are going to be doing today is doing the answer key to this review sheet. Now, here's probably what you want to do. Do the review sheet, check your answers with the answer key and Edline. When it comes to questions that you're not getting right or you're not understanding how to do, that's when you want to view the video. You don't need to view the video in its entirety unless you choose to. You might want to kind of fast forward and pause or whatever you need to do. Okay, so that's how you're going to utilize this video. So we're going to start from ordering, evaluating each expression using the order of operations. On number 1, what I notice is that I've got a -5 that's squared. A -5 squared is 25. I am subtracting from that 5 squared, and 5 squared is just 25. There's a difference between a -5 being in parentheses and a -5 not being in parentheses. This final answer comes out to be 0. In number 2, I work inside my parentheses, and I'm going to do 3 times 7 is 21. Still in the parentheses, I've got 11 plus 21 divided by, I'm going to go ahead and do this right now, 2 cubed is 8, and then I'm going to subtract 1. In my parentheses, when I add 11 plus 21, I actually don't need this parenthesis here. 11 plus 21 becomes 32. That's a 32 divided by 8 minus 1. 32 divided by 8 is 4. 4 minus 1 is 3. The next problem. I'm going to do my exponents first. I'm going to work right here. 2 to the 4th power, I know, is 16. What I did not use was 7 minus 48 divided by and times 6. I now need to do my division because it comes first in order from left to right. 48 divided by 16 is 3. 7 minus times 6. Multiplication comes first. 7 minus 18. The answer, -11. 4, I've got a couple of grouping symbols, so I work with my innermost symbol. That becomes 3 minus 6, which is -3. Understanding that that's still a part of this grouping symbol, this grouping symbol, plus 1. Now I've got my -3 times 4, which is -12. That still happens to be in a grouping symbol. I'm not going to use braces anymore. It doesn't really make a difference. -12 divided by 3, -4, plus 1, -3. 5. I'm going to work inside my parentheses. This is not a -2 being squared. It's just 2 being squared. It becomes a 4. What gets carried down is this negative plus 6. I don't know why this smartboard does some funky stuff. The second parenthesis I'm just going to do as is, -5 divided by 10. And here, -4 plus 6 becomes 2. I'm still in one of those grouping symbols, divided by 10. -10 divided by 10. Again, I don't know why this is doing some funny stuff. -10 divided by 10, and the answer becomes -1. Number 6, evaluate the expression x minus z divided by y plus 1. I'm just going to kind of put in what I know for sure isn't going to get replaced by anything. So I've got a minus sign, a fraction bar, and a plus 1. X is -2. Z is -3. Y is 4. In my numerator, which I have to do first, -2 minus 3 becomes -2 plus 3, or 1. 4 plus 1 is 5, and that's as far as I can go. Somehow something got skipped. Number 6. Number 7 looks like it skipped, so I'm going to put in a new page here. New page. Do I remember how to put in a new page? New page. Here we go. So number 7 says, what property is illustrated by this equation? Explain your answer. So what's happening in 7 is you've got a number sign, a plus sign, a parenthesis, a triangle, plus a heart, equaling a parenthesis with a number sign plus a triangle, close the parenthesis, plus a heart. Well, the order of those symbols stayed the same. However, the parentheses changed. This is an example of the associative property because I don't know why this is smartboard associative property because the order of the symbol stays the same. Stays the same, but the grouping symbols change. Sorry, symbols change. Okay, so that's your 7. Number 8. What's the last step in simplifying this expression? You might as well go ahead and just do the whole thing. So I'm going to work with my exponents first to get my 25. And then I've got parentheses 2 minus 3 times 4 plus 25. Again, I don't know why this smartboard is doing its own thing. I'm going to multiply next for 12. Oh my gosh, this is annoying. For 12. And then I've got 2 minus 12 plus 25. I'm going to subtract negative 10 plus 25. And then this is my last step. The answer happens to be 15, but the question is what's the last step? And the last step is you can either say it's addition, or you can expand that addition of negative 10 and 25. So addition becomes the last thing that you do. Subtract that trinomial from the other trinomial. So from goes first. So basically, if I'm talking about x squareds, from negative 7, I need to subtract negative 3. If I talk about my x's next, from 3, I need to subtract negative 5. If I talk about my constant terms, from negative 10, I need to subtract 8. When I combine all these like terms, what ends up happening is the following. I'm going to get plus positive, or final answer, negative 4x squared plus 8x minus 18. Okay, next. Find the value for pk and a value for n so that 3x plus 2 times 2x minus 5 equals something. I'm only going to worry about this. Let's just multiply it out. I'll go for the area method, box method, lattice method, whatever you want to call it. 3x positive 2. 2x negative 5. As I multiply through, 3x times 2x, 6x squared. 2x times 2x, 4x. 3x times negative 5, negative 15x. 2 times negative 5, negative 10. Combine like terms. 6x squared minus 11x minus 10. What that translates into is p is the coefficient of x squared. Well, the coefficient of x squared is 6. K is the coefficient of x, which means k is negative 11. N is my constant term. N is negative 10. There is your P, your H, and your N, or P, your K, and your N. Okay, next problem. This is just absolutely crazy. I don't know why I'm getting frozen here. I'm going to pause this for a second. Okay, So number 11, simplify the following. I've got the distributed property happening a couple of times. So I'm going to start off with my distributed property, and I'm going to give you some color coding here. I'm going to start off here, and then I'm going to go here, and then I'm going to go here. So my distributive of yellow becomes 6x squared plus 18. My distributed property in green becomes negative 28x minus 21x squared. My distributed property in blue becomes negative 10x plus 5. If you're going to do distributed property again to combine like terms, that's fine. So I'm going to be doing x squareds, and I've got 6 minus 21 of them. I'm going to be doing x's where I actually didn't even write, oh no, sorry. I've got x's where I've got, what do I have? Negative 28, minus 10. And then I've got the constants where I have 18, and I've got plus 5. Again, I apologize about the smartboard. I don't know what's going on here. It's just, hopefully you'll be okay. So my x squareds total to negative 15x squareds. My x's become negative 38x, and my without x becomes 23. Some of you guys might have used the commutative property, and maybe you decided to do your actual constant terms first, and then maybe your x's were last. It doesn't matter what your final answer is. Commutative property is fine. Just make sure you get the appropriate sign with the appropriate value. Number 12, multiply and simplify. So again, we can go into a box. It's a 2 by 2. So if we box it, I don't know why there's a line going across this way. I'm going to box it this way. I'm going to go down, and I'm going to go over. This becomes 3/4 A. This becomes negative 8B. This guy becomes A. This guy becomes positive 8B. 3/4 A times A, 3/4 A squared. Negative 8B times A is negative 8BA. 3/4 A times 8, 3/4 of 8 really just becomes 6. Basically, you can make this a fraction. Top times top is 24. Bottom times bottom is 4. What comes out here is a 6. So this box becomes 6AB. Negative 8B times positive 8B, negative 64B squared. Understand that BA and AB, they are just the commutative property. You can actually combine them. They're like terms. Your final answer becomes 3/4 A squared minus 2ABs, negative 8, positive 6, minus 64B squared. There's your final answer. Let's keep on going. All right, looks like I got to go back to the computer to do this. This is going to make this video even longer. I don't know why it's thinking. I'm going to pause it for a second. Okay, we're back. So now what we need to do is find the product of this 3 by 2. Again, I'm going to go into your area model, lattice, whatever you're calling it. And I'm going to have 3 things on the top and 2 things on the side. 3x squared, a positive 6x, a negative 2, 2x, and a negative 1. 3x squared times 2x, 6x cubed. I'm actually going to go down this time. 3x squared times negative 1, negative 3x squared. 6x times 2x, positive 12x. 6x times, 12x squared, excuse me. 6x times negative 1, negative 6x. Negative 2, 2x, negative 4x. Negative 2, negative 1, positive 2. Combine like terms, final answer, 6x to the third power, positive 9x to the second power, negative 10x, positive 2. Okay. Next, we've got a proof to complete the statement. So we want to show that x parenthesis y plus z plus y parenthesis x plus z is equal to 2xy's plus z parenthesis x plus y. So what we give you, the first step was given. The second statement, how do we get xy plus xz plus yx plus yz? Well, hopefully you realize that the parentheses went away, so we basically used the distributive property. That's how we did that. Then somehow we've got xy plus xz plus xy plus yz. So here, we just kind of changed the order. So we did the commutative property. We actually did the commutative property of multiplication in case you're interested. Then what happens is we've got xy plus xz plus yz. So what basically happened was from this line above it, we switched this order. So we switched the order. We did the commutative property again. This we used it with the commutative of addition where we switched those orders. Well, somehow these guys became this guy. So basically we said, all right, well, if I'm talking about xy's, I've got coefficients here of 1 plus 1. That happens to be combining like terms, or you can consider it to be the distributive property. So whether you do distributive property or you call it combining like terms, I'll accept either one. Lastly, a parenthesis shows back up again, which means over here, we said the z's were in common. What do we have? X plus y, and that's your distributive property. Okay, so that's your proof. Winding down. Next problem. Go back, switch it. Number 15 talks about inserting grouping symbols so you can get something to work. Insert grouping symbols so that we can get 80 to come out. So you're going to be trying some different things, but as it turns out, the way that it works is going to be by putting the parentheses here, because when I actually do this math, it comes out to be 10. That was a times. 10 times 4 squared divided by 2, which means 10 times 16 divided by 2, which means 160 divided by 2, and there's your answer. Next, in the diagram below, ABCD is a square represents the garden your mom is having put in. Each side has a length represented by 2x plus 6, which means this side of the square is 2x plus 6. This side of the square is 2x plus 6. Then it also says that in addition, rectangle WXYZ represents the paved walkway through the garden. It has a length represented by x plus 3 and a width represented by 2x. So this is our paved walkway. And it says that we've got this being x plus 3 and this being 2x. So it wants you to find the area of the garden not covered by the walkway. So we basically want to find out what's not shaded. And it gives you a hint. You need to subtract the area of the paved walkway from the area of the square. We're looking for area. So we basically need to find the area of our square. We need to find the area of our rectangle. And when we subtract the two, you're going to be left with what's not shaded, and that's going to be the garden that's not covered by the walkway. So let's see if we can kind of figure that out. So the area of our square, I'm going to extend this up a little bit. So the area of our square, and that's ABCD, is length times width, length times width. I'm just going to do this as distributive model. I'm not using the lattice method. So 2x times 2x, 4x squared, 2x times 6, plus 12x, sorry for all these crazy lines. 6 times 2x is 12x again. 6 times 6 is 36. So when I combine like terms, my square is 4x squared plus 24x plus 36. Now I need to do my rectangle, and my rectangle is WXYZ. So WXYZ is also length times width, which is going to be, I'm going to go width times length, if that's okay. I could use the commutative property. So it becomes 2x times x plus 3. When that gets done, that's basic distributive property. You come out with 2x squared plus 6x. I've got answers for the area of the square. I've got answers for the area of the rectangle. Again, what we said that we had to do is we had to take the square, it's kind of hidden somewhere in the back, and subtract from it the rectangle. So that's what I'm going to set up now. I'm going to set this up. I've got 4x squared plus 24x plus 36. I'm going to subtract from that 2x squared plus 6x. Again, if we work with the distributed property and combining like terms, I know that for my x squareds, I've got 4 minus 2 of the x squareds. For my x's, I've got 24 minus 6, and those are the x's. And then without x is just 36 minus 0. There's no like term in the other one. I'm just going to put a 0. Don't really need to put anything. So what we end up with for the area of the garden not covered by walkway, area of garden not covered. Final answer is 2x squared plus 18x plus 36. I guess I can go all the way out there. Okay, so once again, the area of the garden that's not covered by the walkway, 2x squared plus 18x plus 36. Last question on the review sheet is about Adam trying to simplify an expression, so that's what he does. He's not right. We've got to find his mistake and then determine the correct answer. So I'm going to actually just go ahead and work with his problem. So 20 minus 1/2 6 squared basically means I've got to do exponents first. What I should be doing, what he should be doing is 20 minus 1/2 times 36. Next, what has to happen is the 1/2 of 36. Well, half of 36 is 18. So then it needs to be 20 minus 18. Final answer should come out to be 2. So we found his mistake. We determined the correct answer, but we're going to write something up a little bit, and we're going to say Adam, he basically took half of 6 and then squared it. So Adam took 1/2 of 6 and then squared that. He was supposed to follow the order of operations and do 6 squared first. Okay? The correct answer is 2. Alrighty, so that's it. Okay, so tomorrow's quiz will be similar to some of the questions that were on here. It does cover from 1.1 to 1.5. Okay, so make sure you go back through your notes. There's lots of examples that we never did in class that you could probably still do. Um, make sure that you go over some of the homeworks and make sure all that's good. Okay, so good job. Hopefully putting the time to watch this video, and we will see you tomorrow for that quiz. See you later.